Hello students, welcome to the next lecture series of basic electrical engineering. Today we are going to start what is the basic principle of DC motor. So we will see what is the DC motor basic principle. So DC motor is a device which converts, which converts the electrical energy to mechanical energy. So it is converting electrical energy to mechanical energy. Whenever you give the electrical input, so it is going to convert the mechanical energy. So what is the mechanical energy it is converting? So for example, if you see your houses, if you observe your motor, so it is converting, you give the electrical energy as the input, so it is converting that mechanical energy. What is the mechanical energy it is doing? It is lifting the water from the ground level, This is the mechanical work it is doing, ground level. So that is the mechanical work it is doing. And the basic principle, what is the basic principle present behind the DC motors is, so when, let us see, when a conductor, that is a current carrying, placed in magnetic field, experiences a force, that is represented by so F is directly proportional to dl bar, that is a cross B. So that is the F will be represented by dl cross B. So this law is known as Lorentz-Ford's law. So whenever a current carrying conductor is placed in magnetic field, it is experiences a force. This law is given as Lorentz-Ford's law. So this is the Lorentz-Ford's law. So we can write it as F is equals to BIL LC sin theta. This is equation we are already know, that is the force. So LC is the effective length and B is the flux density. And the direction of force, very important here, direction of force can be found by using Fleming's left hand rule. So here I will show the diagram, Fleming's left hand rule, the diagram. You see here, you can see the diagram here. So this is the Fleming's left hand rule, the diagram. This thumb, this is the thumb is indicating, so this is the thumb is indicating here the force of the conductors. Next, this forefinger, that is the forefinger, is indicating the direction of the field, that is the field lines, and this middle finger is indicating the direction of current. In this case the current, in this case of the motor it is current, in the case of the DC generator it is the EMF induced. So this is the difference. So middle finger is indicating the direction of the current and forefinger is indicating the direction of the field lines and thumb is indicating the force on the conductors. So this is the Fleming's left hand rule. So you have to stretch all the three fingers in this manner, that is in three-dimensional view, so that you are going to get the Fleming's left hand rule. That means this finger, middle finger, is coming out. So let us see another diagram. I will show another diagram also here. So if the forefinger is like this, see this diagram, if the forefinger is coming out here, okay, if the forefinger is coming out here, the forefinger is going into the, middle finger is going into the plane. Here middle finger is coming out from the plane of the wall or whatever, it is coming out, okay, it is going into, this is the, so the direction will be found. So the direction will be here, that is downwards, the force on the conductor will be downwards, and here the direction of the force will be upwards here, that you have to observe. And this field lines is common here, the field lines are common in case of both condition, okay, but you have to observe whenever the current is going into the plane of the paper or whatever it may be, you have seen it is coming out from the plane of that, so the force will be upwards, the force will be downwards here, you have to observe. So one thing you have to see, the magnitude is given by magnitude of the force, magnitude of force is given by given by Lorentz law, okay. So that is we are already seen Lorentz law, that is F is BIL C sin theta, that is the magnitude. So whenever you want to find the direction can be found by using Fleming's left hand rule. Very important this questions, Fleming's left hand rule. Okay, let us see how to understand how the elementary operation of a DC motor. We will see elementary operation of DC motor by considering, here you can observe, by considering a simple, okay, simple loop DC motor here, simple loop DC motor we will consider. Let us understand how the DC motor is working. Understanding the working principle of DC motor. See here, when a current carrying conductor is placed in a magnetic field, it experiences a force, that is what we have given. So if you observe here, so just I am giving the supply is going like this, you observe here, the supply is going like this to the brush B1 and the slip ring S1, then it is going like this, and this is what the length of AB, and it is going like this CD length, and it is coming back through the slip ring S2 and the brush B2, like this it is going. This is a complete path. So whenever you are place the conductor, it is experiences a force because the current is going into the plane, okay, going into the plane of the paper. If you apply the Fleming's left hand rule on this length of the conductor AB, so what will happen, it will experiences a force. So how the direction of the force, the direction of the force will be the downwards. So the direction of the force on this conductor, it is downwards, okay. Next, so this is the direction of the force on the conductor will be like this. Now if you observe the direction of the force on this conductor, let us see, on this conductor the length of the CD, it is experiences, so because the current is coming out from the conductor, so the force on the conductor will be in this direction. So that means it is the force on the conductor will be, it is going upwards. This you can observe, that means it is going downwards and upwards. So that means it is rotating. In which direction? It is rotating in the anti-clockwise direction, okay, it is rotating in anti-clockwise direction. Let us see in this case, as the brushes and the slip rings are connected here, so what is happening here, whenever the current carrying conductor once again placed in the magnetic field, it is also experiences a force. So this is the conductor of length CD is placed, and AD is, as it is moving, so as it is rotating, so once again what will happen, CD will comes under the influence of the north pole and AB will comes under the influence of south pole. Because of that, what will happen, the brush positions will be changes. So if you observe here, the current is flowing from once again the brush B1, and here it is going into the AB length, then it is coming out from this. So what is happening, this is the path of the current you are applying, because you have to give the electrical energy as the input. So you are giving the electrical energy as the input. So if you give the input that is going into the plane of the conductor or going into the AB length, so the force direction will be in what direction? The force direction will be, you can consider it as like this. That means the force will be on this conductor, that is the length of the AB conductor is, it is coming downwards. Now if you observe the length of the CD, what is the force on this conductor? If you observe, that is coming out from the, coming out from the conductor. So what is the force on this conductor? The force on the conductor will be in this direction. Okay, that means, so it is also, what is happening here, it is also rotating in which direction? So first force will be in this direction, so direction of the force will be, it is rotating in clockwise. Okay, first it is rotating in the anti-clockwise. Okay, now it is rotating in the clockwise direction. So we require, so if you observe the torque or the force on the conductors, if you draw the torque or force on the conductor, so what is the direction will be, it is indicating in the first half cycle, it is producing like this. In the first half cycle, if you observe in the first half cycle, the position of the AB will be at the 2 and the position of the CD will be at the 4, but whenever it rotated, so in the next cycle the position of CD will comes under CD will comes at position 2 and AB will comes at position 4. That means the torque will be reversed here, the torque will be reversed. But we require, we are studying it as a DC motor, we require a unidirectional torque. This unidirectional torque function can be done by, we know already, commutator. Now we are going to connect the commutator. So let us understand the function of the commutator. So this is the, just I have drawn a commutator. So if you observe here commutator, so what is our target from the previous diagram? If you observe the conductor which are under the influence of north pole, always, so it should be always the current is going into the plane or out from the plane. So the conductor which are under the influence of south pole, which should be coming out from the plane or going into the plane, maybe depending upon that what is the electricity you are applied. So whatever it may be, it should be the same in the next half cycle also. That is what our target, to get the unidirectional torque. That function can be done by the commutator. That is what we are going to see here. So if you observe here, so by connecting this commutator, so we are already discussed in the generator video. So what is the meaning of the commutator? Here a commutator is a device which is converting. So I already told, so commutator will do the two functions here. So what it is doing, it is acting like a inverter. Okay, so let us understand what it is doing. If you observe here, so this is the commutator segments. In the commutator segments, it is made up of, so this is separated by a insulating material, that is mica. Okay, this is mica, and we have the commutator segment A and commutator segment B here, and it is made up of hard drawn copper. And AB is the commutator segments here. So whenever you have like this, so A is connected and B is connected to separate brushes, and we are fixing the brush positions here. So they are connected for the brushes. So this is the commutator, and it is acting like a inverter in the case of this DC motor, because you are giving the supply. Okay, because it is you are giving the supply, DC supply you are giving, and it is getting to AC, it is converting to AC. Okay, so it is doing that. So we have to convert this commutator segment by connecting these commutator segments here. For the conductors, we are going to convert it as the variable torque into variable torque or force on the conductor will be unidirectional. If you observe here, so whenever it is conductor under the influence of north pole, this is the north pole. Okay, let us write, this is the north pole. Conductor under the influence of north pole is now carrying the going into the plane, and it is coming out from the CD length. going to the commutator segment B and the brush B2, and it is going like this. Now what is happening after, so the force on the conductor, if you observe, what is the force on the conductor? So the force on the conductor will be downwards. The force on the conductor will be downwards. Now if you observe, what is the force in this case? That is the CD length. For CD length the force will be upwards. For AB length the force will be downwards. Okay. So the length CD is experiencing upwards. So that means these conductors are rotating in which direction? Once again, this is rotating in anti-clockwise direction. Let us see, after some rotation, CD will comes under the influence of north pole and AB will comes under the influence of south pole. So because of that, what will happen? You observe here, the force experienced by the CD length is also once again downwards. The force experienced by the AB length is also upwards. Because of that, what will happen? Once again this conductor length CD and AB is rotating in which direction? Anti-clockwise direction. Anti-clockwise direction only it is rotating. So now you can expect that. So what is the torque? What is the torque produced in this case? Torque produced in this case, you can expect that which is a unidirectional torque. Even after 180 degrees also you can expect the torque will be a unidirectional torque you can expect in case of DC motor. The function what it is doing? Function, the commutator is doing that function because the commutator segments are attached with the number of coils. Okay, this is the basic principle of DC motor, how it is working. And one more thing you have to observe, in the case of the DC motor we have the north pole and the south pole. Let us understand what is the basic principle once again in detail. So in the conductors, if the conductors are placed like this, so the conductor under the influence of north pole, the conductor, it is, let us consider it is a coming out and it is going like this. So whenever the conductor is carrying current is in this direction, so it is experienced a force. So that means, so what is upward? So the force of the direction will be upwards, here it will be downwards. So it is the force is experienced by the conductors. What is the cause of this force? What is the cause? And we are studied from the Faraday's laws. When a current carrying conductor is placed in a magnetic field, an EMF is induced in it. That means in this conductor the EMF also will be induced. Okay, so the EMF will be induced in the conductor will be exactly opposite. The EMF induced will be exactly opposite. Why it is opposing? Because of this EMF only the force is created. So because of that the field lines are going like this. Because of this magnetic field it is placed. So because of this EMF induced in the conductor, so what is happening? The force is created on the conductor, so that's why the EMF will oppose. Okay, what is the cause of this force? The EMF will be is the cause of this force. The EMF direction will be like this. So EMF will oppose the cause of production of the force. So due to Lenz's law, we are already know. So the cause is the production. The cause is will oppose the production of the force. What is the cause here? EMF. So that will oppose the force on the conductor. That's why EMF will be always opposite to that force. That EMF which is induced in the conductor, motor, is known as back EMF. So the EMF will be known as back EMF, which is exactly opposite, okay, to the applied voltage. So how you are getting this current? So first you are applying the voltage. Let us draw electrical equivalent. In this case we have the armature resistance and we have back EMF also will be like this, and you have the terminal voltage. So if you represent, the terminal voltage is in this direction and this is the back EMF and this is the armature resistance. The current is going into like this. So this is the electrical equivalent, plus and minus, here also plus and minus. So back EMF will always oppose. So from this, if you apply the KVL for this diagram, you can get it as, what is the armature current? Armature current is equals to V minus EB divided by RA. V minus EB divided by RA. As you are increasing, so whenever your back EMF is decreased, for example, whenever your back EMF is increases, what will happen? Armature current will be increases. Whenever the back EMF is increased, so what will happen? So the armature current will be decreases. So because of this feature, the DC motor is known as a self-controlling device. A self-controlling device. Because of this feature, we can call it as the DC motor as self-controlling device. So armature current can be controlled, okay, whenever the back EMF is changes. And also one more possibility is here is, you can control the speed by changing the armature resistance also. Whenever you are decreasing the armature resistance, armature current will be increases. Whenever you are increasing the armature resistance, armature current can be decreases. These are the possibilities you can control the DC motors. Let us understand, so what is happening in case of DC generator. So if you observe in the case of the DC generator, so we have to give the mechanical energy as the input. So whenever the conductors are placed like this, so let us see, the current is going into and the coming out. So whenever you are rotating this, you have to give the mechanical energy for the DC generator. So it is rotating in the anti-clockwise. So we are giving the mechanical that is a mechanical energy we are giving like this, that is we are rotating in the anti-clockwise direction. But because of the force on the conductors, the motor is trying to rotate in the clockwise direction. This torque is known as electromagnetic torque. Always the electromagnetic torque is opposite to the torque what you are applied. So that to overcome this electromagnetic torque, we have to give some more mechanical energy. That mechanical energy is extra. That is extra mechanical energy you are giving here to overcome this opposition. Okay, to overcome this opposition, that extra mechanical energy is converted into electrical energy. So that is the main function in case of DC generator. So that is the basic difference between the DC generator and the DC motor we can observe here. Okay, that's all for today's class. We will see in the next video what is the torque equation of a DC motor, and in the next video we will see what is the different types of DC motors. If you are seeing the first time this channel, please like, share and subscribe the channel to your friends, which is very useful for your external exams. Thank you.